Here, this is how one has to proceed. So how many terms do we have? Each time you pick one of from each parenthesis, you pick E1 term, but you can do this only once. I can choose E1 term from this, then I will have E1 alpha 2 over alpha 1 E1. Then I cannot pick this one, so I need to pick E3 and then E4 up to En. For the second term, I'll pick E1 term this time from the second parenthesis. So if I choose this term, then I cannot choose this term because it will be 0. So I have to start with this one. The plus E2, and then here coefficient is minus alpha 2 over alpha 1. And then I have E1 up to En. And it will go like this, right? Each time I will pick E1 term from one parenthesis. First from the first parenthesis, then from the second, then from the third, and so on. And this will exhaust all the possibilities because each term should have one E1 term in it. Therefore, and you can choose E1 term only from one parenthesis. Right? Yani bütün terimlerde sadece bir tane E1 olabilir. Dolayısıyla da her bir parantezden ben bir kere E1'li terimi seçebilirim. Bir tanesinden de E1'i seçtiğiniz zaman geri kalan parantezlerden E1'i seçemeyeceğim abi. Dolayısıyla geri kalanları seçeceğim. Ne kalıyorsa. O yüzden ilk parantezden seçersem E1'i bunu elde edeceğim. İkinci parantezden E1'i seçersem bunu elde edeceğim. Aynı şekilde gelecek. 50 parantezden E1'i seçersem I will have this, and then I have to pick up the rest. So it should be like E2 and then E3 up to E and no, En minus 1 and then E1. Evet, ve ondan sonra ne yapacağım? Şimdi bütün bunları alfayla çarparsam, if I multiply everything with alpha 1, this alpha will go away. Efendim? Bir de o var, evet.
O da yanlış.
Evet, bir de hiç E1'lerin olmadığını seçebiliriz. O da E2, En olacak. Haklısın. Alfa 1 ile çarpınca I will have alpha 1 factor here. Burada da and here you see I have minus alpha 3. E3 is missing here, right? The next term here is E4. And then it goes like this, En. And if you want to write this as E1, E2, and so on, you can do this. You have to interchange these two, E1, E2, but then you have to change this sign. So each time you do this, burada da E1 kaç tane atlayacak? N-1 tane atlayacak. Şurada sanki işarette bir sıkıntı var ama neyse. So this will jump and come up here, E1, E2, En, and so on. And it will have alpha N in front. This time should be maybe minus 1 to the power of minus 1. Whatever. So you will get the following. Alpha 1 times this gadget is equal to alpha 1 times this term, alpha 2 times this, alpha 3 times this, and alpha n times this gadget. And this whole thing is just nothing but this omega. So that's the idea. It's something similar to this one, but it is easier is the following. If dimension of D is equal to n, then this gadget any n vector is of the form V1 to Vn. Ya da şöyle diyeyim, E1 up to lambda times E1 En. Yani verikler E1 En is any basis. Therefore, any n form has this form. In particular, dimension of the this thing is just 1, because any element of this vector space, any n form, is just a multiple of this element. There is only one element, and you just take multiples of it. Why is that? This is even simpler. Why? Because of the following. Actually, this is something we have considered several times. So, any n form can be written as like this, E1 up to the n, right? Sums of things like this. However, any element like this, so V1, Vn can be written how? Well, this V1 can be written like this. Since E1 up to En is a basis, I can write it like this. A1, 1 E1 up to A1 and En, wedge product, and then the second vector can be written like this: A21 E1, A2 and En, and up to nth element an1 E1 up to an En. And then when you open these parentheses, again we have the same game. If you pick, for example, E1 from this, you cannot pick E1 from this one, right? You have to pick E2, E3, or something else. But if you say if you choose E2, then you cannot pick E3, and so on. So each time you have to pick one element which is not picked before, right? Previously. So you will have something like this. You will have you will pick up some element here, I1, or şöyle yazayım bunu, sigma 1, E sigma 2, E sigma n. Sigma is what? Sigma is a permutation of Sn. Yani mesela şunu olabilir. Sigma 1 could be 3. Sigma, this could be 3. For example, this could be 5. and then 2, and this is, let's say, 2. Okay. Just the permutation, a one-to-one on function from the index set to itself. Sn. And then, of course, you have this coefficient. So here, if you are choosing E sigma n, what is the coefficient, or sigma k, let's say? What is the coefficient? That coefficient is just A1 sigma k. If you are choosing sigma L, what is the coefficient here? A2 sigma L. So here the coefficients will be as follows: A1 sigma 1, and then A2 sigma 2, up to A and sigma n. Okay. Yani her birisinden so here Sn is the set of all permutations of 1 up to n. Okay. You just consider all the permutations, meaning that you pick one element from each parenthesis, but each time you choose a distinct element. So if you are choosing E5 here, you cannot choose E5. You have to choose E6 or E1 or E2, E3, here different elements, meaning that this sigma is a function from 1 up to n into 1 up to n, but it should be one-to-one function. Okay? Yani ilkinde 3'ü seçtiyseniz ikincisinde 3'ü seçemezsiniz. Başka bir tane seçeceksiniz. Değil mi? Onu sağlamanın yolu, you choose a one-to-one function, but you have to choose all functions. Therefore, this summation is over all permutations. Tamam mı? Her seferinde bir eleman seçmek demek, farklı eleman seçmek demek, yani bir permutation'a göre seçmek demek. Değil mi? İlkinde ilk parantezden üçüncüyü seçtiyseniz, ikinci parantezden üçüncüyü seçemezsiniz. 1'i, 2'yi, 4'ü seçebilirsiniz ama 3'ü seçemezsiniz. Diyelim ki 2'yi seçtiniz. Öbürsünün bir sonrakinde ilk ikisini seçemeyeceksiniz. O yüzden bir farklı seçmeniz lazım. Dolayısıyla birebir bir fonksiyon olması lazım. Orası anlaşılıyor mu? Yani niye birebir bir fonksiyon, dolayısıyla bir permütasyon seçmem lazım? İstiyorsanız hani bir tane açıkça yapayım. So let me just do one example in detail. So let's say V1 reach, V2 reach, V3 reach, V4. So here I have A1, 1, 2, 1, A1, 2, 2, A1, 2, 3, A1, 4, 4, which A2, 1, 2, 1, A2, 2, E2, A2, 3, E3, A2, 4, E4, which A3, 1, E1, A3, 2, E2, A3, 3, E3, A3, 4, E4, which A4, 1, E1, A4, 2, E2, A4, 3, E3, A4, 4, E4. So when you open this up, if you choose E1 here, you cannot choose E1 because it will give you 0. You can choose E2, right? So E1, let's say I choose E2 and then E3 here and E4, right? I have wedges, of course, like this. Okay. E1 wedge, E2 wedge, E3 wedge, E4. And what will be the coefficient? A11, and then A22, A33, A44. This is one element. Let's choose another element, some other element. Let me choose this one, A13. So I have E3. And then I cannot choose this one because it will give me 0. I can choose this element, A22. So I have E2. And then bunu seçeyim. E4. So what's the coefficient? A34. And then I have to choose E1. So A41. Okay. You see, this corresponds to which permutation? This corresponds to the permutation which sends 1, 2, 3, 4 to 1, 2, 3, 4, right? If you compare with this one, so here you see 1 sigma 1, 2 sigma 2, and sigma n, right? So here 1 is mapped to 1, so sigma 1 is 1, sigma 2 is 2, sigma 3 is 3, sigma 4 is 4. But here, sigma is what? 1, 2, 3, 4. First one is mapped to 3. Second one is mapped to 2. 3 is mapped to 4. And 4 is mapped to 1. Okay? You have this. Right? Each term, of course, here, how many terms should I have? There are 2 choices here, but then there are 2 choices here, because if you choose one of them, you cannot choose that vector here. There will be 2 choices here and 1 choice here. So 24 terms. Okay? 24, which is just the order of this symmetric group, of course. Right? Permutation. So for each permutation, you have a term. Okay? And this whole thing is just this summation. Anyway, so what we get will be the following. Okay. So here we see the following. Any n form is a sum of wedge products like this, but each wedge product of n vectors is just something like this. And you see here this gadget. So this doesn't have to be E1, E2, E3, and so on, right? It's something like this. The first term could be E1, E2, E3, E4, but here it is not E1, E2, E3, E4. It is 3, 2, 4, 1. But by just switching the terms, I can make this as E1, E2, E3, E4, right? So 1, 2, 3, and 4. How can I do this? Well, I have to just count how many permutations or transpositions I apply. And it is nothing but how many transpositions you can represent this term as a product, right? This is the composition of transpositions, and you have to just count the number of transpositions. Yani orada ne diyoruz? Sign of sigma, number of transpositions to write this permutation. Okay, so let me do this. Bu nedir? Şimdi
Yani transformasyon 3, 1, 3, 4.
yani şey yapıyor, 2'yi sabit bırakıyor. Değil mi? 1, 3'e gitmiş. 1, 3'e gidiyor. Yani 1, 3, 3 de 4'e gidiyor. Bu ne şey? Bu da nedir? 3, 1. Efendim?
1, 4, 3.
1, 4, 1, 3. 1, 3'e gitti. 3, 4'e gitti. Tamam. 4'te 1'e gitti. Tamam, doğru. So sign here is plus. Next one could be minus and so on. Tamam mı? Sonuçta ne gördük ama? So, what is the conclusion? Hence, any element omega here and in this has the form. So it had the following form D1 up to the end, and you have some of these elements, but each one of these is nothing but elements like this, so they are just E1, which and there is some constant here. So this thing is just actually, this element is just constant, therefore this is just some constant C times E1, E_n. Therefore, any n form is just a multiple of this element. Okay. Peki.
How conclude the dimension?
So any element is the product of the single element. Right? The coefficient is just C. Yani any element kendini like this. C times this element. Yani o da şuna denk geliyor. N boyutta n boyutlu hacmi veren bir tane nesne var. Yani ona denk geliyor. Okay.
Bir vektör içinde toplamları içinde
Nasıl? N-1'ler içinde. Ama orada n tane şey var. Basis'i onun bir değil.
Evet, ama toplam şeklinde yazılmış. Orada da aynı şekilde.
Yok. Evet. Bunu onu yapacağız. Okay, now next we will see that we will compute dimension of polynomials on V, where dimension of V is equal to x. Aslında yani şunu biliyoruz zaten. This is, wedge of only one vector. Well, if you have one vector, this is just V. And actually, by convention, the zeroth wedge is defined to be just the base field. Okay, base field. First wedge is itself. Second wedge is just thing like this. BR, WI, right? Two vectors, and so on. Now here, what is the base of this? Well, let's say this is the basis, let's say E1 up to En. What is the basis for this? Well, a basis for this could be, two vectors. We may have E1 wedge E2, right? If I have this, I don't need E2 wedge E1 because it is just negative of this. I may have E1 wedge E3 up to E1 wedge En. And then I have what? E2 wedge. I cannot have E1 because it's already there. But I may have this E1 wedge E2 up to E2 wedge En, and go like this up to En minus 1 wedge En, right? So each time I will have one less element. And what should be the, so actually for the basis I can just take this step, EI wedge EJ. Here I is strictly less than J, and they range between 1 and N. Şöyle nesneler aslında. EI wedge EJ'ler öyle ki EJ'den küçük. Because if it is bigger, then you can just switch it. You will get the same object, right? Negative of that element. Yani E1'e 2'yi alırsanız E2, E1'e gerek yok. Değil mi? E2, E3 varsa E3, E2'ye gerek yok. O yüzden her zaman base elemanlarını, indekslerini böyle sıralı seçebilirim. O zaman da boyutu ne olur bunun? And choose 2, right? So dimension of this is just and choose 2. This is and choose 1. So what about this guy? Dimension of which is it and choose k, right? And we will prove this. Okay, that's the next thing we are going to do. Yani şöyle yazayım onu. Okay, so let the dimension of V is 10. Then dimension of kth wedge power of V is and choose K and beta. So I1 which VIK where I1 is less than I2 less than IK. And like this, all between 1 and n, between 1 and n, so is a basis. Here, of course, beta is a given basis. Is a basis. Yani beta'nın bazı E1, EN ise bunun bazı bu şekilde batch product'lar olarak alınabilir. Product of K basis elements with increasing indices. Okay. The proof of this is similar to what we have done for tensor products. There we had also some business, for example, to show that why these elements are linearly independent. So, like in tensor products, that was also the main difficulty, showing that certain elements are linearly independent. Yani şunlar niye linearly independent? I will for different indices, why these are linearly independent. There we had used some linear maps and so on. Similar ideas necessary for this proof. But let me just postpone this for a while, okay? I guess you understood more or less what's going on, but I'll come back and do this proof. Now let me skip to actually next chapter and talk about determinants. Göstermemişim galiba. If there is a vector space of dimension n, we want to compute the dimension of k exterior power. Here, by zeroth exterior power, we will always denote the base field. First exterior power is just V. Second exterior power, elements like this. And the basis for this will turn out to be this gadget. Okay. And from this, we read that the dimension is just n choose 2. And similarly, k's exterior power will have dimension n choose k. And the basis for that is just a set of such elements. So you have a wedge of k elements of the basis with increasing indices. Okay, increasing indices. But I'll do the proof later. This one. Now let's pass to chapter 3. Says basic applications. And the first one is determinants through permutations. I'll just give the definition, but then we will not go into that into details. What is the permutation of an n by n matrix? So say Aij is a square is an n by n matrix. Its determinant is defined to be the field element determinant of a given by şöyle determinant A dediğimiz şey şu olacak. Determinant of A. Just this expression, okay? You don't have this EIs, basis elements. We have just this. Here, of course, you see, in this case, I can just write one more line here. What's that line? I can just write this as by switching the terms, I can arrange this and obtain the following. E1, here of course I have wages. Wage E2, wage En, and here of course if you do this changes, there will be a sign, and sign is just the sign of the permutation. And then you have here what? A is 1, sigma 1, A, and sigma N. And summation over all permutations. And then determinant of A is just, you erase this part. Determinant is just this, okay? So determinant is just the following object. Over all permutations, sine of sigma, and then A1 sigma 1 times A2 sigma. A2 sigma 2, A and sigma N. Okay. For example, what is, for example, determinant of a 2 by 2 matrix? Example, A is, let's say, A11, A12, A21, A22. So determinant of A is what? So is 2 sine of sigma A1 sigma 1 A2 sigma 2. Well, S2 has 2 elements. S2 has 2 elements. One of them is identity permutation, and the other one is just 1, 2. So there are only 2 terms. If I choose the identity, sign of identity, and then A1, if this is identity, sigma 1 is just 1, and then A2, just sigma 2, plus sign of the permutation 1, 2, A1, sigma 1. Well, this is the permutation 1, 2, so it sends 1, 2, 2, 2, and A2, sigma 2 is just 1. And what is sign of 1, 2? It is just one transposition, therefore this is just minus. Therefore we get 1. A1, 1, A2, 2, minus A1, 2, A2, 1. Okay? This is, of course, something you already know, right? What about the determinant of 3 by 3 matrix? A1, 1, A1, 2, A1, 3, A2, 1, A2, 2, A2, 3, A3, 1, A3, 2, A3, 3. Of course, we have seen the determinant previously, but just to see that this definition is nothing but the same thing. I'm just repeating the computations. So here this time we choose permutations. I have 6 many terms. Right? S3 is just identity, and then 1, 2, 1, 3, 2, 3, and then 2 more elements, 1, 2, 3, and 1, 3, 1, 1, 3, 2. Right? 6 elements. Okay, and then A1 sigma 1, A2 sigma 2, A3 sigma 3. So what will be the elements? If you choose identity element, sign is 1 because it can be written as a product of 0 transpositions. 0 is an even integer. And then identity maps 1 to 1, 2 to 2, 3 to 3. So this is just A1, 1, A2, 2, A3, 3. And then this element, its sign is minus. So sign of this, and it sends 1 to 2, 2 to 1, and doesn't touch 3. And then plus sign 1, 3. So 1 is sent to 3, 2 is sent to itself, 3 is sent to this, plus sign of 1, 2, 2, 3. So 1, 1, 2, 3, 2, 2, plus sign of 1, 2, 3. So 1 is sent to 2, 2 is sent to 3, and 3 is sent to 1, plus finally 1, 2, 2. So 1 is sent to 3, 2 is sent to 1, and 3 is sent to 2. Okay, and it turns out that so this is of course -1. This is also -1 because it's just one transposition. This is -1, but these are +1. This is +1, and this is +1. And what we get is just the previous description of the 3 by 3 determinant. But you see, I mean, this way, obtaining the determinant, okay, it's nice, but actually it's difficult to handle because it has many terms. Of course, since we have already studied match products, we can just give geometric interpretation of determinant. as the volume. Why? Well, given an n by n matrix, let's say Aij. Here Aij's are in some field state. Okay. Consider a vector space B over K of dimension and with basis, let's say E1 up to E. Define the vectors. B1 şu olsun. Birinci sütunu alayım. Birinci sütunu alınca ne olacak? A1 E1 A2 E2 değil mi? N1 N bu şekilde gidiyorum. Bn olacak. Ya da B2 ile yazayım. B2 A1 to E1 A2 to E2 N to En and similarly En is just nth column. Nth column is just 1 and E1 2 and E2 up to and E1. Değil mi? Yani şunu yaptım. 1 and 2 1 2 2 and 1 and 2 and 10. So I just take this column and write as the coordinates of these vectors in this basis. Okay, now what would be the weight of these vectors? Now, V1 wedge, V2 wedge, Vn will be 1. So this is A11 E1, A21 E2, An1 En. Wedge product, second element is A1 to E1, A2 to E2, up to A and to En, and then we have wedge product up to and row 1 and E1, 2 and E2, and En. And if you open this up, what you will get? Okay, now her birinden bir tane eleman seçeceğim. Aynı elemanı seçersem 0 olacak. If I choose same index ENs from two of them, I will get 0. Therefore, from each parenthesis, I have to pick up only one EI. That shouldn't be the same from the same as the ones you have chosen from the other ones. So if I, for example, choose second element here, I shouldn't choose second element. I have to choose first one or third one and so on. So what you get is something like this. I'll choose some elements here. I can write it as a permutation. The first, okay. I choose, let's say, sigma 2, no, sigma 1. So sigma 1 is 2, and then E sigma 2, E sigma n. What is sigma? Sigma is a permutation. Değil mi? Hangi elemanı seçtiğini söylüyor. İlkinden işte buradan üçüncü seçtim, dördüncü seçtim, beşinci seçtim. Bunları söylüyor. Peki katsayıları nedir? What is the coefficient here? This is from the first element. If this is sigma 1, yani mesela 2 ise o zaman seçtiğim eleman nedir? 2'ye 1. Yok. Özür dilerim. Sigma n. Yok. Sigma sigma 1. Sigma 2 değil mi? Şöyle olacak. Sigma n.
Buna yani İslam gelmesi lazım.
Aslında yani bunu da Sigma'nın inversüyle şey yapabilirim. Zaman bitti mi? Okay, let me stop here. I'll continue next time.